Once upon a time, Sally was playing outside with her friends when suddenly she tripped and skinned her knee. This is when Sally's endothelial cells started to get working. Sally's endothelial cells started to contract. Why did this happen? Sally's endothelial cells started to release chemical factors called endothelians at a super quick rate. This stimulates the smooth muscle contractions, which promote vascular spasm and accelerate the repair of her knee. This is called the vascular phase. Near the end of this phase, the endothelial plasma membranes become sticky, which prevent blood flow and help the platelets attach, leading us to the next phase.
Within 15 seconds, Sally's platelets are releasing chemicals and proteins that play a role in this clotting process. These factors are activating aggregation and secretion to form the platelet plug, where they are continuing to induce vascular spasm and promote clotting and vessel repair. This phase is called the platelet phase.
The next phase doesn't start until 30 seconds after Sally scrapes her knee. This phase is a positive feedback loop, which includes an extrinsic pathway, intrinsic pathway, and a common pathway. The extrinsic pathway is faster and shorter, acting like a quick fix that will later be reinforced by the intrinsic pathway. The extrinsic pathway releases a proenzyme, which interacts with calcium ions to create an enzyme complex that will activate factor 10 in the common pathway. The intrinsic pathway activates another proenzyme, which interacts with calcium ions and platelet factors to create an enzyme complex that will also activate factor 10 in the common pathway. Once factor 10 is activated, it activates Sally's prothrombin activator, which will convert her prothrombin to thrombin. Thrombin then converts her fibrogen to fibrin, which completes the clotting process. This phase is called the coagulation phase.
The next phase continues over 30 to 60 minutes. In this phase, Sally's knee makes the damaged site smaller for her cells to repair. This stabilizes the injury site and reduces her bleeding. This is called clot retraction. But Sally's knee can't stay clotted forever. Sally's injury will later go through a process called fibrinolysis. In this process, two of her enzymes will activate the proenzyme plasminogen, which will produce plasmin to digest the fibrin strands and eradicate the clot. Thanks for following Sally's cells on their journey to repair. Sally's all better now thanks to hemostasis.